Good morning, children. This is our science period. As you know, we were in chapter number 9, Soil. Children, we have already studied about the different types of soil. We talked about the soil profile, and so now we will be studying about the properties of soil. So, as you know, we have already listed some of the uses of soil, such as pot making, making of the toys, making of the statues, etc., from the clay soil. So, children, now let us perform some activities to find out the characteristics of the soil. So, we will start up with the first characteristic, that is percolation rate of water in soil. So, what is percolation? Percolation is the passing of the liquid or the gas through a porous material. The rate at which water percolates through a particular kind of soil depends on the texture of the soil. The percolation rate is different in different kinds of soil. So here, Buzo and Pehli marked two different squares of 50 centimeters into 50 centimeter each. One of the floor of their house that they have taken and was your paved or the pakka one, and the other one was the kacha or the unpaved road. They filled the two bottles of the same size with water. They emptied the water from the bottles, one each at the same time, in the two squares. So they observed that the water on the floor flowed down and was not absorbed in the pakka pavement, either the pakka road. On the other hand, the kacha road, the water was absorbed. Now, let us perform an activity to understand this. But here, Buzo wanted to know that why there was a difference in the absorption of water in these two squares. So, children, as already I discussed, that percolation of a liquid or a gas depends on the size of the material that is used. So, it depends on a particular kind of soil depending on the texture of the soil. So, it will be different in different kinds of soil. So, for this activity, they have divided, either we can divide the team into three, A, B, and C. You will find out how fast the water passes down in the soil. You will need a hollow cylinder or a pipe. Ensure that each team uses the pipe of the same diameter. Some suggestions for obtaining such a pipe are given below. If possible, get a small tin and cut it off at the bottom. But if PVC pipe is taken, it should be approximately of 5 diameter centimeter and cut it into 20 centimeter long piece and then use it. At the place where you collect the soil, the pipe about 2 centimeters deep in the ground. Pour 200 ml of the water in the pipe slowly and slowly. For measuring 200 ml of water, we can use empty 200 ml of bottle. Note the time when you start pouring the water into it and when all the water has percolated, leaving the pipe empty. So, after leaving the pipe empty, note the time again. But be careful not to let the water spill over or run down on the outside of the pipe while pouring. Here we can calculate the rate of percolation by using the formula, that is amount of the water, which will be in ml, upon the percolation time. So the formula once again you can see is percolation rate of water is equal to amount of water upon the time taken. So suppose for an example, here we are taking a sample of 200 ml of water which percolates within 20 minutes. So our rate of percolation will be 200 ml upon 20 minutes is equal to 10 ml. So I hope you have understood how to calculate the percolation rate of water. So rate of percolation is equal to amount upon time. So here amount is 200 and the time taken is 20. So we get is equal to 10 milliliters per minute. So this is how we can calculate the percolation rate of water. Now we'll compare our result and arrange it in increasing order with the help of the percolation rate which has been found by the other two teams. This is how diagrammatically you can see how the pipe was arranged when the percolation was of the water was taken up within the soil. The second characteristic that we will be talking about is the moisture in the soil. So have you ever passed through a farmland during a hot summer day? If yes, then you might have noticed that the air above the land is shimmering. But why is it so? So for this answer, we will be again performing one activity which is given as 9.5 in your textbook, for which we will take a boiling tube. We will take 2 spoonfuls of soil in this boiling tube. We'll put it on the flame and then we will observe the test tube. What happens to it after heating? So here, do you see any water droplets anywhere in the tube? If yes, where did you find them? So here we can see the sample of the soil at the bottom of the test tube here, we can see how we are burning it, either heating it. And here we can see that it has started boiling, and even we can see the droplets of water. So this is how we are going to arrange that test tube. Here we find that on heating, the water in the soil evaporates, it moves up and then condenses on cooling in the inner wall of the upper part of the boiling tube. So the same phenomena goes on the hot summer day also, where the vapor coming out of the soil reflects the sunlight and giving the appearance to the soil as it shimmers. After heating the soil, take it out of the tube, and then you can compare this soil with the other soil which is not heated, and you can see the difference between the two. That is, one is containing the moisture and the other one which is without the moisture. So children, today we studied about the two characteristics of the soil. One was percolation of water in the soil, and the second one was moisture in the soil. For you, today's home assignment is how the rate of percolation in soil can be calculated. Hope so you have understood both the topics. Thank you. Sai Ram.